Hi, everyone. Good morning, good afternoon, good evening, depending on where you're located when you're logging into this webinar. Welcome to the Institutional Scaling webinar hosted by the International Ecological Footprint Learning Lab. My name is Peri Dworatzek, and I'm excited to be moderating this hour-and-a-half session today. I'll start with a little bit about myself. I'm the Partnership Coordinator for the International Ecological Footprint Learning Lab, along with being a PhD student at York University, which is based in Toronto, Canada. I've been working with the Ecological Footprint Initiative, which is a member of the International Ecological Footprint Learning Lab for a few years, and I've co-produced a few editions of the National Ecological Footprint and Biocapacity accounts, along with a set of city-scaled ecological footprint and biocapacity data. A little bit about the International Ecological Footprint Learning Lab, or we can refer to it as EIFL. It is a multi-stakeholder international partnership bringing together academics, practitioners, and students to research sustainability informatics, specifically ecological footprint metrics and methodologies, to face the pressing environmental and economic challenges around the world. The International Ecological Footprint Learning Lab also draws on research supported by the Social Sciences and Humanities Research Council of Canada. So the focus of this webinar today is looking specifically at sustainability assessments that have been done at institutions of higher education. So we have examples from across Canada and from in Sri Lanka. And all of our panelists today are part of the International Ecological Footprint Learning Lab as either partners or collaborators. So keeping in mind that, of course, we're not the only people who are doing sustainability assessments at post-secondary institutions. And in fact, there are many other groups and researchers conducting this type of work. One example is EU STEP. They're a project designed to educate European university students and the wider academic community on the complexity of sustainability and its interdisciplinary nature. So to broaden out our understanding and perspectives of this work and research that's being done, Eric will talk more about these projects around the world, and we'll start with that presentation first. But just a little bit about our plan for the webinar today. So we have 4 presentations. So before we start our presentations today, I'll introduce our 4 amazing speakers. So our first speaker today is Eric Miller. He is the director of the Ecological Footprint Initiative based at York University. Eric manages multiple projects, including the production of the National Ecological Footprint and Biocapacity accounts. He teaches footprint-related courses, supports students and project staff, and supports the Footprint Data Foundation as its secretary-treasurer. Then we'll hear from Kiona Lo. Kiona serves as the Senior Data Analyst at York University's Ecological Footprint Initiative. She holds a Master's in Environmental Studies and a Business and Environment Diploma, which are also both from York University. Kiona has experience quantifying environmental impacts across metrics and scales, and she has co-produced 2 editions of the National Ecological Footprint and Biocapacity accounts. She has also produced York's second greenhouse gas emissions report, which she'll speak more about today. Our next presenter is Dr. Hemanthi Ranasinghe, a senior professor at the University of Sri Jayewardenepura in Sri Lanka in the Department of Forestry and Environmental Science. She is also a research collaborator with the EIFL Partnership and has a long-standing relationship with York University, where she was an adjunct professor from 2014 to 2016. In more recent years, Hemanthi has focused her research on climate change mitigation and adaptation strategies, including conducting collaborative research with national and international organizations, such as the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. And finally, last but not least, we'll hear from Dr. Jennie Moore. Jennie is one of the co-directors of the EIFL Partnership. She's also Associate Dean of the Building Design and Construction Technology and Director of the Sustainable Development and Environment Stewardship Departments at the British Columbia Institute of Technology. Jennie has launched sustainability-focused industry practices, educational standards, and a groundbreaking employee trip reduction program. And so those are our 4 speakers for today. So I look forward to hearing from you all. And so now I'll pass it over to Eric to start off the presentations.
Okay, thank you for this opportunity. So I'm going to speak to the broader context of applying ecological footprint and or biocapacity to higher education institutions. And so when we're talking about higher education institutions, we are talking about universities, colleges, polytechnic institutes, and similar organizations that are beyond the levels of what are typically referred to as primary, secondary education. And so you will be hearing about all sorts of great examples of very specific initiatives, but I want to preface the presentations that are going to follow from me with the point that ecological footprint and biocapacity has been applied to many higher education institutions. And so you will hear about specific applications related to York University, to the University of Sri Jayewardenepura, and also to the British Columbia Institute of Technology. But before going into those details, I'd like to reflect on sort of a broader sense of evidence of applications to many higher education institutions. And so one of the ways to reflect on this is to make use of the academic literature about the application of ecological footprint and biocapacity and its application to higher education institutions. And so here's a plot to start things off from 1992 and then the 30-year period since then of English academic journal publications focused on ecological footprint and or biocapacity. This is the cumulative number of publications over that time period. And it starts in 1992 because that's the first academic publication that defines and qualifies the concept and the measurement of ecological footprint and its relationship to biocapacity. And that was from William Rees at the University of British Columbia, that publication dated in 1992. Since then, there's been a lot of exciting work that's been captured in academic journal publications over this time period. And about 4% of those publications relate to the focus of the application of ecological footprint and biocapacity to higher education institutions. And so focusing just on those papers that apply that, this is a plot of the number of new publications in each of those years over that 30-year time period. And so you can see that the application at the level of higher education institutions is recorded as starting in 2001. And so in that publication year, there are 3 publications, one from the University of or applied to the University of Redlands in California in the United States. Another one is the Open University in the United Kingdom. And then the third one is at the University of Newcastle in Australia. And so since then, there's been quite an interesting set of scholarship in this area. But reflecting, of course, that this is only sort of a sample of the scholarship. This is the scholarship that is recorded as academic journal publications. And the details of the applications that you'll hear from our next 3 speakers are not included within these bars, although they might be shortly with future academic publications. But making the point that there's a lot of work on the application of this that goes beyond academic journal publications. And so it is possible to access a lot of reports online. And it's also certainly possible to engage with our research initiative, and we're keen to sort of build up a community of practice sort of in this regard to make it more obvious as to how to connect all of ourselves around the world who have been doing this and are keen to see more of this done in the future. When we look at the number of publications per country of corresponding author, you could see that there's a good level of diversity across countries, although there are many more countries in the world who are not represented on this list, but possibly have also engaged with this topic as well. So going beyond this sort of broader context of its application to many higher education institutions, I'd like to reflect on the sort of case for why to do this. Why should we go through the effort of applying ecological footprint and biocapacity at the institutional level, specifically about higher education institutions? Well, there's several reasons for this, and perhaps the first point to reflect on is that it helps higher education institutions to measure and disclose their carbon footprint or their greenhouse gas emissions. There's a lot of demand for doing this, and in order to derive ecological footprint, we also need to derive emissions because, of course, carbon emissions is one component of an ecological footprint, together with other components, including built-up land, including cropland, grazing land, forest land used for forest products, and also fishing grounds, and then also the area needed to sequester carbon dioxide emissions from human activities. And so there's a lot of demand for this. Some jurisdictions require these sort of assessments to be done. So, for example, the province of British Columbia requires institutions of higher education or universities, I believe, to be having some measure of sort of disclosure around this. And it's really interesting that even a lot of university level surveys about programs are asking information about this. For example, the Financial Times does an evaluation and comparison and scoring of various MBA programs around the world. And one of the attributes that earns points associated with that is whether the business school has done an assessment of its carbon footprint, and if it has, whether it's public or not. It's also good to do this because that provides reportable evidence of these institutions engaging in sustainability, and this is increasingly important because there are at least like 24 initiatives around the world to score universities related to their engagement with topics like sustainability and partnerships and so on. There's, of course, things like the STARS program that some of you on the webinar might be familiar with. There's the Times Higher Education Impact ranking applied to, I think it's just universities, although it might also be colleges and polytechnic institutes as well. And of course, going through the effort of deriving the measurement of ecological footprint and biocapacity can help to inform operations and sustainability strategies on campus, as we do here at York University, and as many of the papers that I've read and the other reports that I've read have seen and signaled as well. This is also a great opportunity to generate data which can be used in teaching projects and publications, which of course is a great rationale for doing this. And as part of that, there's a great opportunity within the higher education institution environment for experiential education with students as data analysts. So it's not just the analysis and the outcome, but it's also the process of getting to there to engage students in that. And of course, you can build institutional capacity and recognition in sustainability informatics. There are, of course, a lot of challenges associated with applying this. There's, of course, the usual challenges with any institutional application around data access. The units are typically not physical, they're typically monetary, converting them, etc., supply chain details, and all the rest, as we've covered in other webinars. But there are specific challenges related to higher education institutions. A large portion of the higher education ecological footprint is indirect, or scope 3, which is certainly a feature of that we'll be hearing from shortly. And of course, the challenge of situating this capacity, whether it's centralized or distributed, and what faculty or department engages with this. This is about computations. It's also about environment. It's also about strategy. It's also about visualization and communication. And of course, the challenge of sustaining capacity and interest in evaluating transformative and transformational outcomes. These challenges, of course, can be addressed through knowledge mobilization and partnerships among higher education institutions, such as our partnership of the International Ecological Footprint Learning Lab, and the partnerships that the members within that have, such as what Peri mentioned in the introduction related to EU STEPS. So with this, I'll pass it over to Kiona Lo to share insights of the experience applying this at York University.
So thank you for having me to speak. So I'll be talking about how York measure its ecological footprint. So first, a little bit on the background. So this project has started because York has asked our team at the Ecological Footprint Initiative to quantify its greenhouse gas emission. And because we also produce the National Ecological Footprint and Biocapacity accounts, we took it one step further to calculate the footprints for York as well. And from this, we have produced 2 reports on York's greenhouse gas emission from fiscal year ending 2016 to 2023, primarily using Microsoft Access, a database tool, as our main tool. One thing to note here is that we've only produced footprint in the first report until fiscal year 2020. We hope to do it for the extra years in the second report, now that some of the converting factors that we use are updated. And just like how the project has started, we follow the same order on how we quantify York's footprint. So we started with quantifying York's emissions first, and we use them to help us calculate York's footprint. So my presentation will also follow the same order, where I will focus on the emission side first, and then moving towards the footprint part. And to quantify or to measure York's emissions, we follow the Greenhouse Gas Protocol as our framework. Emissions under this framework are separated or categorized by 3 of the different scopes, but then we adapted our own component to the ones that are most relevant to a university setting. So the 3 scopes, scope 1 being the direct emissions. So these are the emissions that are produced right from York's campuses or by York's assets. An example of this would be the electricity generated from the cogeneration plant at York's campus. Scope 2 and Scope 3 are both indirect emissions. Scope 2 are the indirect emissions related to energy use, such as electricity that is purchased from the grid. And Scope 3 are the rest of the indirect emissions. We have 6 categories under Scope 3, such as procurement, business travel, and commutes. And to quantify all these emissions, it all comes down to this single equation right here, where emissions is equals to activity data, which is the amount of activity that generates emissions, multiplied by the emission intensity. So how much greenhouse gas is produced per unit of this activity. And activity data comes into 3 different types. We have physical quantity, expenses, and distance, and each of them correspond to the type of approaches that is taken to calculate emissions. Quantity-based is the most straightforward, where the 2 of them are more complicated. So I'm gonna elaborate on them next. So we use the spend-based approach to calculate our procurement emissions at York. Procurement emissions are the ones that are embodied in the products and the services that we purchase. They are generated throughout the life cycle, from raw material extraction to the finished product. And they're highly relevant to post-secondary institutions. And to measure the procurement emissions, we adapted the equation that was on the last slide into this one, which essentially we take the amount York has spent in a sector in a year, and we multiply it by the average emissions that is produced per dollar spent for that sectors. And then we sum it all up for all the sectors that York had purchased to get the total procurement emissions for that year. So the first part of this equation, which is the activity data, it comes from York's non-salary expenses by the account. And then the second part of the equation, the emission intensities, they come from Statistics Canada. There are the national average emission intensity from Canada, and we have it for around 110 sectors. One thing that is kind of behind the scenes and could be tedious and challenging or even overwhelming when you're doing it on your own is that you have to match the accounts, but the expense accounts with the sectors where the emission intensities are available. So how we did it was we match each account to up to 3 sectors and prioritizing those with the largest spendings. Now, moving on to the second method that I want to profile, and this is the distance-based approach, which we've used to calculate emissions generated from York's community driving to campus. So like the previous example, we adapted the core equation to this one for the distance-based approach, where emissions is equal to the total distance that the York's community has driven to campus in a year, multiplied by the emission intensities per distance travel. This emission intensity comes from the International Energy Agency. But the challenge here to calculate this emissions is to get the total distance driven by York's community in a year. And in order to solve this, we looked at our parking permits data. So this is the sample data. In this, it tells us that in the parking data, it tells us that who is driving to campus. It also tells us the distance, or tell us where they're coming from the postal code in the sample data, as well as how many months they commute to campus. So by using the postal code to map the trip distance and applying assumptions on how often a student or staff or faculty commutes to campus in a work month, we were able to estimate York's annual travel distance, and using that with the emission intensities in order to calculate the final commute emissions. And so with this, it brings us to the results of York's greenhouse gas emission. So on this graph here, I have York's total emissions with all the 3 scopes. If we look at them in aggregate, we can see that York has reached its peak emissions back in fiscal year 2019. And then we had a drop because of COVID, but now we have since recovered, and this is in fiscal year 2023. When we look at it by scope, we see that the largest and the most variable one is scope 3 emissions in this darker shade of red. It is larger than scope 1 and 2 combined in almost all the years. It's also showing more variability compared to scope 1 and 2. And this next graph here shows us the breakdown of what makes up each of the scope, just like the table that I saw in the very beginning. So the blue bar, it shows the level of emissions in year 2023. The red dot shows the level of emissions in 2021, which is the COVID year. And then the arrow bar shows the emissions from 2016 to 2023. And it's also separated by scope. So focusing on the bottom here, which are all the components of scope 3, here we see that scope 3 emissions at York is largely driven by its procurement emissions. So emissions from capital expenses, and also emissions from goods and services, as well as commuting emissions. And here you can also see how low the emissions were, almost close to 0 in the COVID years. And now, with all the emissions part that I went over, we can finally switch gears to talk about the footprints. So in order to calculate York's footprint, how we've done it is we use the emissions that we've calculated and also the expenses that we have gathered through that calculation process. So in order to calculate the forced carbon uptake component, we applied emissions, the greenhouse gas emissions with yield factors. And to calculate the rest of the component, we applied expenses with the consumption land use matrix table. So it is essentially a table that translates $1 of the expenses into units of footprint component based on which sector the expense were incurred. And on the other hand, the biocapacity side is a little bit easier. So York's biocapacity was just derived from the area of the 3 York campuses, including the one in Costa Rica, which also includes several conservation area and forest. And now here we have York's total ecological footprint in fiscal year 2020 in this tree map. So here you can see that around 80% of the total of York's total footprint is covered by the land that is needed, the forest area that is needed to absorb York's carbon emissions. You might also notice that there's a York logo in the corner here and wonder what it represents. This logo is actually drawn to scale to the footprint, and it represents York's total biocapacity. So currently, our biocapacity only covers 1% of York's total footprint. In order to be self-sufficient, York would need a campus that is 85 times larger than its current size in order to be self-sufficient. So we see a very stark difference between the biocapacity and the footprint, but it's also kind of as expected because we don't expect a university in an urban setting to be self-sustaining. However, this shows us how by using ecological footprint, it will allow us to have a deeper understanding of our total impact, not only focusing on our carbon emissions, but also focusing on the area that is needed to provide us what we need in the university. So with this, I want to conclude the presentation with some lessons that we have learned along the way of doing this footprint and emissions calculation. So first, when you're doing this project, you will need a lot of data, including the more sensitive ones like the expenses. And with this, it is extremely important to build trust with the team that you're getting the data from, as well as to build trust with senior leadership to have their support to get access for these detailed data. And second, in addition to trust, you might need some more push in order to get the data or to start the project, to start measuring emissions and footprints. And in these cases, something we can leverage would be both external and internal demand. So kind of like what Eric mentioned, maybe your university wants to submit some emission data to the rankings, or maybe perhaps the business school is looking to submit for their own ranking as well. So it would be helpful to leverage these kind of demands to help you get the data or to get the project started. And after getting the data, you might be tempted to calculate the emissions and the footprint in spreadsheets. While we did do some processing in Excel, we mainly use Microsoft Access, like a database environment, for the emissions and footprint accounting, just because of the sheer volume of data, components, and equations there were, as well as there were significant data cleaning that were needed. So in my experience, it was easier to do large-scale data cleaning in Access in a database environment comparing to using just spreadsheets. And the next one, I only mentioned it briefly when I went over procurement emissions, but just as a head up, when you calculate emissions from expenses, it could get challenging and involve many assumptions. So it would be very important to document all the assumptions so we have a clear sense of what has happened in the process. But despite all this work to get the data and then clean the data and also to put them into all the calculations to calculate emissions and footprint, the findings are extremely useful to help us understand the sources of emissions and footprint, which can also help us create future scenarios to make better and more informed decisions. So with this, I hope you find this presentation helpful, and I look forward to the rest of the presentations and also the questions in the Q&A sessions. So now I will pass it to, I think, Hemanthi with the next presentation.
This one is ecological footprint and biocapacity assessment of our university, which is University of Sri Jayewardenepura. And it is actually an undergraduate research project, which I and Professor Miller supervise. And her name is Ms. Veerakudi, and she has joined the webinar, so she'll be there. Tarushi Veerakudi. So the little bit about the profile of our university. It is 20 hectare. We have only taken the main campus and only the medical faculty, which is in close proximity. But campus is very large, and spread in other areas also. But most of the faculties are housed in this main area. So students, there are about 16,000 students, that is 15,000 undergraduates and 1,000 postgraduate students. And the staff, we have 1,500 academics and 1,200 non-academics. And also in 2022, we have the campus has achieved the recognition first carbon neutral university in South Asia because we have modified our carbon and offset it against forest restoration efforts which our campus has done. But why we do this one, we decided to do this one, there has not been a continuous monitoring of that effort. And even the data, for some reason, went missing. So therefore, we thought that, especially since I have these connections with the York University, and I thought that it would be nice to be part of this wonderful network, so that we can add value to it by doing a similar study in our university. So we continuous monitoring is needed for, even if we want to pursue this, the certification that we have obtained, and also updated baseline for planning, progress evaluation, and ongoing commitment towards sustainability. So the study objectives are comprehensive ecological footprint and biocapacity assessment to conduct a complete ecological footprint and biocapacity assessment for the university using international recognized methodologies. International benchmarking, provide comparative analysis with York University's Ecological Footprint Initiative to identify best practices, because we thought that it would be nice to, do some comparisons also. Professor Miller was so kind to share the reports, the study reports done of the ecological footprint work in York University. Then determine main drivers of our university's ecological footprint across all emission scopes. Actionable recommendation, develop specific prioritized recommendations for reducing environmental impact, and to establish a baseline, to create robust baseline for future sustainability monitoring and reporting. So we used the GHG protocol methodology to calculate the carbon emissions, and also to calculate the ecological footprint. We use the global footprint network methodology. And so the reporting period is from 2022 to 2024. So we use these three scopes: direct emissions, indirect emissions, or indirect scope 2. This is the indirect energy, and other indirect emissions. That is all direct greenhouse gas emissions from sources owned or controlled by the university, and indirect energy is indirect emissions from the generation or purchased electricity consumed by the university, and other indirect emissions, that is all other indirect emissions occurring to the university's value chain, often the largest category. So we have explained, and I just want to say what we have taken in these scopes. Scope 1, we have taken university fleet vehicles, emergency generators, boilers and furnaces, campus shuttle services, and laboratory equipment, and using direct fuel. And scope 2, we have taken grid electricity for buildings, academic facilities, and student hospitals, and laboratory equipment, and outdoor lighting, and HVAC systems. And for the scope 3, we have taken student and staff commuting, procurement of goods and services, business travel, air and ground, food services and catering, waste generation and treatment, water consumption, and capital goods and construction. So how we collected this data, we don't have a systemized approach like your university, so it has to be done manually. So my research student whose picture is here, she really went into a lot of trouble collecting this data from all the divisions in the university. So we collected the electricity consumption, metered data, complete monthly records from all facilities, then university fleet travel, complete fuel purchase reports, and vehicle mileage logs. Water consumption, utility bills with monthly consumption data, waste generation, that is volume-based estimates from hauler records, university-funded travel, including travel destinations, duration of stay, and purpose of travel, and purchase goods and services, including the capital goods, and HVAC systems and refrigeration equipment. So this is how we calculated using this greenhouse gas protocol. Activity data was collected, then we converted with the emission factors to emissions. Then we aggregated by scope, and then we converted to global hectares. So the results, I just show some results because the main emission category was scope 2. In our case, it was electricity. And as you could see that it also has increased with time. And so therefore the emissions also has increased. And then fleet fuel, it showed a reduction in increase in 2023. But anyway, although reduced compared to 2023, it shows a upward trend. And then generator diesel, and because this in 2022 there were a lot of power cuts, and so that was generators were used, but it had reduced, and so the emissions also had reduced. Official travel also is seen like this, and so the emissions also accordingly. And university-funded travel records, of course, goes up, mostly because of vacation leave, sabbatical leave, conference leave, and study leave, where people go abroad, and cleaning and services spent, and thus the emissions. And capital goods, this is according to the GRNs. Then emission by scope, when you come to this, all the emissions that we have taken and compared by scope, we could see that even it has gone up with the years, over the years. And the main one which you see in blue was scope 2, which is the purchased electricity. Compared to the York University, I think it was more scope 3, but we have higher scope 2. Then per capita indicators, this is to the carbon dioxide emissions per capita is in red, and global hectares per capita is in blue. But unfortunately, we only have at this moment data from 2024. But we will include the other years also when this work is completed. So when you compare our the biocapacity, you could see that our USJ carbon global hectares and compared to the York, of course, it's smaller. So this is a sort of a snapshot of the scopes, so that the scope 2 is the highest, then scope 3, and then scope 1. And this is the biocapacity, and this is the extent of vegetation in our campus. So we calculated the acreage extents, and so when we calculated it, we used this reference as global footprint network parameters. So forest cover is 6.94 hectares, built-up cover is 13.1. So we use this equivalent and yield factors as per the Global Footprint Network and came up with this figure. So this is the balance, and the total footprint is this much, and total biocapacity is this much, so that the deficit ratio is 71.36. So compare the global average is shown as 2.8. Our average is 1.24. So still, we might say that we can be a little happy. So recommendations based on our work is that we need to really take stringent measures to reduce the electricity, the purchase electricity. Largest emission is because of that. Then establish a centralized data management system, which we don't have. So we have to be going all over the place and spend a lot of time in procuring the data. So we need to follow the York University model for that. And then quantify procurement-based emissions, implement spend-based emission factor methodology for goods and service procurement, prioritize high-value categories in this case. And then the conclusion is our university has successfully established a verified ecological footprint of 4,523 global hectares against a biocapacity of 63.38 global hectares. So, therefore, the deficit is 75 per 1, and our per person per capita footprint is 0.24. So it's good that we actually, this is, we need to build on this one more, but then it's really good to have some sort of a snapshot of where we are in our university. Thank you very much.
So I had a unique opportunity to do my master's with William Rees at the time that Matthijs Wakkernagel was developing the ecological footprint, and participated in the original working group working with researchers at the University of British Columbia and Matthijs. And then I also had only in hindsight can you see how this comes together, and it's relevant to how this footprint was done, had the opportunity to be Metro Vancouver's first, immediately after graduating, first greenhouse gas, air quality planner in charge of climate action, doing greenhouse gas emission inventories, and also then the first demand side management planner. So looking at energy material flows across the region and how we might work with communities to shape the demand rather than just focus on supply, and went on to become Metro Vancouver's first manager for strategic initiatives, coordinating a sustainable region initiative. And then after that 10-year period working, I went back and did my Ph.D. again with William Rees, looking at everything I'd learned and applying it to a novel application for ecological footprinting based on energy material flows analysis and integrated life cycle assessment. And so the reason why that approach seemed to make sense to me, and I was asked not to work with the global footprint accounts, which are essential, I might add, to doing this work, but just because the interest was there to see how would a planner who's worked in city management approach this same question. And so this work, after that, my PhD was supported through the British Columbia Institute of Technology, and I went on to work there for the last 20 years. So this approach to ecological footprinting, which we did in 2009, and so I'm just showing you this report that we did because we wrote it as a manual for how you might do this. Granted, it's 20 years ago now. We wrote it as a manual for how you might approach doing an ecological footprint assessment for our institution. We have 5 campuses at the British Columbia Institute of Technology, but this is our main campus at in Burnaby. It's 50 acres, and our thinking was that if we write up this methodology, it will be easier for us and others to do it again. We never did. So, but when I read it for this presentation, I'm like, oh, actually, it's still kind of interesting. So we did what we called a hybrid approach, a hybrid ecological footprint, where we were working with the component methodology. So looking at the actual energy material flows of what was coming on the campus, supplemented by consumption data based on purchasing accounts, where we couldn't actually get the, because back in that day, we weren't tracking energy material flows that much. So if we had the meter records for how much electricity, we could get the gas, we knew that, but we also have been historically relying on money as a symbol for our energy material flow. So where we didn't have the actual data, we had to rely on the money. But as Kiona also already mentioned, sometimes you end up with some abstraction from that. So I always try to go for energy material flows first. But the hybrid piece is then we also worked, of course, with the ecological footprint accounts. And at the time, we were trying hard to establish a system for BCIT to continue to manage its ecological footprint and its carbon emissions generally. And so we were also pushing for we were calling it a sustainability systems, or it's based on environmental systems management, to institutionalize that at BCIT. And I'm just going to scroll down, very, very quickly. If you're interested in the report, it walks you through defining the goals, the data collection, the methodology, how to interpret results, and recommendations for future research. But I wanted to just scroll down very quickly. And I'm sorry, with this, I can't actually see. Just do it this way. Almost there. So this is our energy material flows, how we map it out, right? So first we're looking at this is even prior to all the useful definitions around, scopes 1, 2, and 3 were already out, but not commonly used. So how we did the district energy use, the water energy, food. So again, like scopes 1 and 2, direct energy consumption on campus, how much water, food and food packaging, consumable products. Then we're looking at travel, both in terms of the fleet management, which would fall into a scope 1, energy and emissions associated with our fleets. But then scopes 3 is commuting by our staff, and then our built environment. So this is how we organized that data. And then going into the footprint, this is the data output. So we managed our footprint data based on these different kinds of things that we thought people would be interested in. And so I'm going to change now to the presentation that we did to communicate to our community the output results. And I just want to mention also, Eric mentioned that in British Columbia, all institutions, post-secondary institutions, are required to be greenhouse gas neutral. And that's actually all public sector institutions. So, and that started in 2008, the year before we published our study. So we were able to also benefit from our institution reporting on electricity consumption, gas consumption, and also, interestingly, paper. So BCIT requires all post-secondaries and all public sector institutions to report on that, which is a scope 3 emission. So this is our footprint report. And I'll just go very quickly, but I think one thing that's interesting is how we communicated this data created an explosion of interest in our institution around ecological footprinting, because it could relate back to the units of measure that different departments were working with. And it did take time. We were very fortunate to have a faculty person who I supervised her research, and it took her a year. So a lot of data to collect the data and write the report. So we were lucky because she was on a sabbatical. She was interested in this. She had the opportunity, and we had a dean at the time who was interested in supporting the funding for her time to do this work. So you can just see here some of the drivers. The last thing I'll say on this is that based on this and the interest that we got in 2014, BCIT was able to put reducing our ecological footprint into our policy 1010 on economic, social, and environmental sustainability. It's the second highest policy at BCIT after Policy 1000, BCIT's policy on how to create policy. So Policy 1010 is an umbrella policy. It's based on 7 goals. And it was at a time when we had generated interest and belief that ecological footprint was a valuable metric. Not everybody bought in, but a lot of people did. So that was very helpful. That study was very helpful for us to also create policy. So these are our goals: to reduce our ecological footprint and to become greenhouse gas neutral, a net energy producer, achieve zero waste, become water balanced, ecologically restored, equitable and socially responsible, and accessible to all students and faculty. And for us, I'll just skip ahead here because a lot of this you'll already know. So this is our methodology. So looking at mass flow analysis, life cycle data, and economic input-output methods. So the hybrid approach of real tangible data with the econometric data that a lot of people, certainly in cities and here on campus, were not familiar with. So you can see this is old data from Living Planet back in the day when the footprint was lower, just contextualizing Canada and our campus. And I'll get back to why I think this was really helpful for us to engage our university. So when we did our total ecological footprint, we were able to show BCIT, so similar to Kiona's presentation, but this I think adds a little bit of nuance or interest because we mapped the actual demand against a map so people could see what happened. And we said Burnaby's, BCIT's ecological footprint just for the Burnaby campus, remember we have 5 campuses, just for the Burnaby campus, is equivalent to all the land in Vancouver plus almost half of Burnaby. So again, similar, like 85 times the size of the campus. This is just a different way to contextualize that data and show that actually if all of Vancouver's land and half of Burnaby's land, these municipalities, were dedicated just to operating our campus, that's what our ecological footprint looks like. And I think that helped people really kind of stand up and take notice. So these are the general categories that we were attributing to our footprint. And because it's consumption-based, component derived, we did talk about the translation to cropland, pasture land, fishing ground, but we really focused on the consumption side components so people could relate to it, right? They could relate to the energy use in buildings, food and packaging, consumables, etc. So just very quickly, I'll go through it. This is our ecological footprint for our building operations. This is for food. And food packaging was, especially the brand name juices, was huge, the bottle pops and etc. So that really got people's attention because we sell a lot of bottle pop in vending machines on campus. Looking at this is our consumables. Again, the products that some of this had to be supplemented by dollar purchasing because we for wood, for example, we could actually quantify the wood, but for a lot of it, we had to rely on dollar purchasing. And for commuting to work, what's interesting is that air travel was half of our footprint. So at the time, that really woke people up. And since then, our coordinator for employee development was really hammering down on trying to reduce our air travel, which wasn't so popular with some of our faculty. But anyway, she got inspired from this. And looking at public transit and cars, this is for commuting to work. And then looking at energy use in the buildings. So land use. So classrooms, lodging, offices, education, and then parking. So we have a lot of parking on our campus. And then waste going to landfill, again, focusing in on the embodied energy and materials in addition to just the waste. So we know that from supply chain, the majority of the materials are in the supply chain, and what we touch and handle is a very minuscule amount over time. So the airplane example is just showing how verbally, we were just talking about how much energy materials goes into building a plane versus the amount it's used for flying. Total water footprint. This was an interesting one. So we realized that it rains twice as much on campus as the total water we use. So that was surprising to people because we are in a situation in our region where we rely on snowpack and snowmelt to carry us over the summer months when it's drier. And as we're losing our snowpack to climate change, what we learned is that it rains twice as much as we need. So if we were able to capture our rainwater, then we would be able to be water self-sufficient. Of course, that would mean a massive rethink of how water flows on our and whether or not we are trying to catch any of that water over the course of the year. So that's just looking ahead. Remember, this was 20 years ago. Looking at our waste generation, we really honed in on the quick disposables around our coffee cups, which we still use a ton of, disposable coffee cups, but really trying to push for mugs. So our cafeterias started an incentive program where you could get 10 cents off your coffee if you brought your own mug. And as I said, it just generated a lot of interest for us on campus. So this is our things that people can relate to. industry, plastic pop bottles, glass bottles, paper, gyprock, textbooks, like how much paper is in our textbooks, and pushing to resell them. And of course, now we've gone a lot to electronics, so this is quite dated almost. And then reporting our emissions. And so because 2008 was the first year that public sector institutions in BC had to report their greenhouse gas emissions, we were also able to show this in ton CO2. And as all the other presentations, we did an energy material flows, and we did the greenhouse gas emission inventory. But interestingly, we started with energy material flows, and then derive the emissions and supplement those emissions with the input-output data. So comparing ourselves to other institutions, we also look at our energy intensity per square meter of operation built space. And Burnaby campus was at the low end of the average for institutions that we are other public sector institutions in British Columbia. So we are quite proud of that, but we hold ourselves to a very high level because one of our leadership is in training for net zero buildings and high performance buildings. So we also initiated our campuses as living labs to say we should really practice what we teach. If we're teaching people how to be sustainable, how to manage energy in buildings, and we should be building our buildings that way and managing them that way as well. So I'll whip through this a little bit faster, but this is looking at how we can move forward. So looking at green roofs, we have a Center for Ecological Architecture, looking at how we use green roofs, how we manage renewable energy on campus. So we have some solar photovoltaics. This is our first photo installation that students did, designed by architecture students, installed by electrical and construction students. And it's still active, but it doesn't feed any of our buildings. It's just, but you can actually monitor the energy it's producing. But now we've supplemented that with a lot more photocells, district energy, and other things on campus. And composting, we've had a compost program for a long time, promoting, we now have an edible landscape campus. We do not have a herb garden on our green roofs, but we do have bees. And so we work with an apiary to produce honey. We call it BCIT honey. And then this is the water idea. So right now we are very focused on naturalizing delating our streams, creating tributaries to manage our flooding, because as a climate impact, we have a lot more rain intensity of storms. We've had a lot of flooding challenges. But one idea would be then to also then store that water. So you can see here, like just thinking about, do we want to create storage facilities on our campus the next time we build, rather than putting a parking lot underground? Should we be putting an aquifer or a cistern underground to help us get through summer water shortages? So these are all the kinds of conversations that this can spark. And remember, this was 20 years ago when all of these ideas were hypothetical. And 20 years later, I can tell you now, we didn't do any of it, but now we're getting a lot. We're getting even more water intensity peak flows. And so we're adapting over time. But I think this study still has some relevance even many years later. So I'll just kind of finish this up and say, one of the things that's been interesting in this research is that at the time it generated so much interest, we were overwhelmed, and people wanted to meet with us and answer questions and ask us to do supplementary studies. And we could have literally just done that forever. Like they started asking, well, what's this for? Should we go from plastic to wood? Like, what's the ecological footprint difference of this? And we were like, okay, like we could start a whole study program around that, but we didn't have the capacity. And we tried to do our ecological footprint again because we created this manual in 2012. We hired a consultant to try and replicate the study. We didn't have the faculty available anymore. She was fully teaching. Her loads were busy. And the consultant, we weren't able to finish the study. So they got halfway through it. And then so it was very unfortunate, but for external reasons, they couldn't finish the study with us. So one of the lessons learned here is, we've got these great nuggets of effort and insight, but that sustainable systems management, the kind of thing that enables you to continue to practice it, we didn't succeed with. And so I would say that that's also a lesson learned for us, is if you're going to put the effort in, how do you make sure you have the longevity and staying power to reproduce these studies over time? So even though we have it now in our policy, we haven't been tracking it. So, all right. Thanks very much.
Thank you so much to all of our presenters today for sharing the insightful research, and thank you to the participants for joining us and asking these questions. All of this is possible through the International Ecological Footprint Learning Lab and its partners and collaborators and other members. If you have any other pressing questions, feel free to reach out to our email, the EIFL email that was shared at the beginning of the webinar. Thank you. Bye-bye.